Welcome to a new episode.
Hey everyone, and welcome back to the Copper Connection podcast, the place where we turn textbook, site work and real life trade experience into conversations that actually make sense. As always, I'm your host Chris Bailey, and today we're diving into something that does not always sound exciting on the surface, but it quietly controls how buildings are run, how much they cost, how green they are, and even what kind of jobs you'll be doing in the future. We're talking about data sources in construction and building services. Now, before you switch off data, I signed up to fit pipes, not sit in an office spreadsheet. Stick with me. If you want to stand out as an apprentice or trade student, understand why certain decisions get made on site, and have a real shot at progressing into supervisory, design or even manager roles, then understanding where the numbers come from and how they're used is a massive advantage. So in this episode, we'll break down operational cost monitoring, where the money goes once a building is up and running, enterprise systems, the big software packages that track everything from materials to wages, utilities, meters and building management systems, how buildings talk about their own performance, and infrastructure and transport data, the bigger picture that shapes the projects you end up working on. All in plain English with real world examples you'll recognise from site, college or your part-time job. So grab a brew, put your feet up or keep your earphones in whilst you're working on the tools, and let's get into it. So let's start with operational cost, also known as running costs. Imagine this, you just helped finish a shiny new office block, the last snagging list is done, the client takes the keys, everyone gets their photos for LinkedIn, and you move on to the next job. But for the building owner, that's where the real bill starts. Operational costs are everything it takes to keep a building alive day to day. Wages for staff, utilities, gas, electric, water, internet, maintenance and repairs, that boiler that's always going wrong, rents or finance cost, sales and general admin expenses, even the cost of cleaning and security. Now here's the key point. A higher quality building with good design and well installed building services can actually be cheaper to run over its lifetime. Let's say you're working on a big commercial building. The client chooses cheap kit and basic controls now, or higher quality equipment, better installation and a smarter heating system. The cheap option might save money today, but 10 years of high energy bills, consistent breakdowns and call-outs can cost way more overall. This is where data comes in. By monitoring operational costs, how much you are spending on heating this building each month, how often are you paying for emergency call-outs, are we spending more on repairs because the original design was poor? Clients and facility managers can see whether a building is performing well or bleeding money. And there are extra operational costs people often forget. That's staff gym or canteen, adapting spaces when business changes, like converting open plan offices into smaller rooms. Even the choice of temperature controls affects productivity. Trying to concentrate in all day in an office that's like a sauna or an icebox, people work slower, complain more, and that has a real cost. As an apprentice, understanding this helps you see why designers and managers care so much about kit efficiency, pipe routes, controls and layouts. It's not just about getting it working, it's about how much it will cost to keep working. Now, let's zoom out and take a look at the business side. On a large construction or building services project, there isn't just one person with a notepad trying to track everything. There's an entire enterprise system. Big software packages that run behind the scenes. These systems help with data analysis, spotting trends like which sites are more profitable, information flows, getting the right info to the right people, and reporting, making sure the boss and sometimes the government gets the numbers they needed. You might hear people talking about the ERP, Enterprise Resource Planning System, or the CRM, the Customer Relationship Management System, or just the system. that everyone complains about when it goes down. Think of an ERP system as the central nervous system of a construction company. It connects accounting, budgeting and forecasting, human resources, who's working where, inventory management, how many valves or lengths of copper are in stock, supply chain management, what's ordered, what's delayed, even energy management and performance reporting. All those bits of data come from different departments, sites, stores, accounts, HR, but they all land in one integrated system. So what are the pros of an integrated system? It can speed up workflows. No more chasing 5 different spreadsheets. It helps make better decisions. For example, which sites are making money, which are burning cash. It gives a standard naming system. So a value isn't called 6 different things by 6 different people. But there are some cons. It can be expensive to set up. It might take 2 or 3 years to fully implement in a big company. Everyone needs training, and migrating old data across takes time. Why should you care as a student or an apprentice? Well, because the job of the futures in the construction aren't just on the tools. They're in the planning, estimating, energy management and facility management. The people who understand both the physical side, pipes, ducts and wiring, and the data side, how it's tracked and reported, are the ones who move into supervisory and management roles. So when you hear someone talking about logging it in the ERP or check the system, that's a key part of modern construction data. And it influences everything from materials you have on site to whether a project is seen as a success. So let's move back to the building itself and talk about utilities and building services. Utilities are services that are provided by external companies, like electricity, gas, water, internet and telephone. These providers control how their product is delivered and where the ownership boundary is. That's the point where the responsibility stops and the building's responsibility starts. You might hear this called demarcation point. Then we've got building services. That's everything the building provides internally. So heating and cooling, hot and cold water systems, ventilation and extraction, internal lighting, sometimes private power like solar panels or generators. Building services engineers sit right in the middle. They have to coordinate with utility providers, make sure there's enough space for plant rooms, risers and distribution routes, ensure safe access for maintenance. Nobody wants to service a fan coil unit squeezed behind a ceiling you can't reach, and integrate all that with the architect's design. Now, there are some private utilities, things like the building produces itself. Now, there are also private utilities, things like the building produces itself. For example, local diesel generators, solar PV arrays on the roof, wind turbines and boreholes for water. All these systems can be buried, fixed to the building, suspended in the air or even wireless, and they all generate data, usage, performance and faults. On top of that, building service engineers have serious responsibilities when it comes to information for planning and design. They provide data on building orientation, which way it faces, how that will affect heating, cooling in the daylight, location and size of louvers and windows to balance heat gain, heat loss and natural light, and position visible external equipment, like chillers or flues that might affect planning permissions. They also create utility statements, how the building connects to existing networks, where substations or plants might go. Drainage information, foul and surface water connections to sewers and soakways. Ventilation and extraction statements, crucial for restaurants, workshops, labs, or anywhere with fumes. And lighting layout, where fittings go, what light levels are needed, and how beams spread across the space. All of this relies on accurate data. As someone coming into the trade, you might be asked one day to help gather the data, do surveys, record information, or even update drawings. Having a basic grasp of why it matters puts you a step ahead. Now let's talk about how we actually measure what's going on inside of a building. First up, we have metering. To meet Part L of the building regulations, that's the bit focused on energy efficiency. New builds and major refurbishments often need a metering strategy. Meters and submeters also allows us to see how much energy different systems are using, check if the building is performing as designed, and spot whether energy and money is being wasted. But here's an important statement. A good metering strategy is an essential energy management tool. However, it's the action that results from the analysis and interpretation of the data that saves energy. In other words, meters don't save energy by themselves. It's what people do with the data that matters. Key objectives of metering include ensuring systems are efficient, collecting data for regulations and reporting, helping with design and investment decisions. For example, should we replace an old boiler with a heat pump? Informing infrastructure management, like when to upgrade a main supply, and making energy data visible and usable. You might hear references to CIBSE, TM39 and TM31. These are guideline documents used by professionals to design good submetering strategies and energy logbooks. You don't need to memorise them, but it's worth knowing they exist, especially if you're moving towards building services, energy or facility management roles. Now, let's move to the brain of the building management system, or BMS. A BMS is a computer-based system, softwares and hardwares that can monitor and control HVAC, heating, ventilation and air conditioning, lighting, energy systems, fire and security systems, smoke detectors, alarms and CCTV, ICT systems, lifts and smart meters. Think of BMS as the control room you sometimes see on big sites. Screens showing temperatures, alarms, plant statuses and schedules. A good BMS can show how the building is performing in real time, allow managers to change settings for better performance, provide visual data via a user interface, generate reports on performance, run time schedules so systems can only run when needed, rise alarms and alerts when things go wrong, and compare performance between buildings or against benchmark data. But, and this is important, control systems can also be a big source of problems. Poor design or wrong control concept, cheap, low-quality sensors, systems that weren't properly commissioned, and maintenance that's not done or done badly. If people are too hot or too cold or consistently overriding the controls, the building wastes energy and users get frustrated. Maintenance teams play a huge role here. Even if they don't install the original system, they can spot issues, fix faults, and improve the control strategies over time. Now things are getting more integrated. BMS can now be linked with building information models, BIM. So actually performance can be compared with what was expected at the design stage. This helps identify design problems, operation issues, and even improve future modelling. Take that one step further and you get BEM systems, Building Energy Management Systems. A BEM is essentially a BMS that's been programmed specifically to focus on energy-related systems. For example, HVAC, lighting, and power systems. Here, the control strategy takes into account how different plant items interact with each other, the synergy between systems. Done well, this can massively reduce energy bills and your carbon emissions. For you as a learner, the takeaway from this is if you're comfortable around control, sensors and data, you'll be in demand. Those skills sit right at the intersection of practical trade work and modern smart building technologies. So to finish off, let's zoom all the way out to the national infrastructures. In the UK, there's 13 critical national infrastructure sectors, including energy, water, transport, communications, health, and more like defence, emergency services, food. If all of these fail, the impact is huge on the economy and people's lives, and on the work we'll all do in construction and the building services. There's several big data sources that feed into how and where projects happen, such as the Critical National Infrastructure Database, the National Infrastructure and Construction Procurement Pipeline, which shows planned investments, the Office of National Statistics, the UK Government's Infrastructure and Projects Authority on gov.uk. From these data sources, you can find when new transport links are planned, how the UK is investing in electric vehicle charge infrastructure, update on energy infrastructure and emissions, major projects in process or in the pipeline, and annual reports and project delivery framework. So why does this matter to you? Because all of that shapes where jobs are going to be, what skills will be in demand, like installing EV chargers, working on district heating systems, or maintaining energy efficient buildings, where the construction and building services interests are heading over the next 5, 10 or even 20 years. If you can keep half an eye on these bigger data sources, you can start to plan your own career path. Are you interested in sustainable energy, smart buildings and controls, or large infrastructures like railways, hospitals, or data centres? The data is out there, and the people who understand and use it are the ones who end up leading teams and shaping the industry. So let's pull this all together. We've looked at operational cost monitoring, the real running costs that kick in after handover, and how higher quality design and installation can save money long term. Enterprise systems and ERPs, the digital backbone that tracks materials, labour, energy and more across a business. Utilities, building services and engineering data, how buildings connect to the outside world, and how engineers use information to design safe, efficient systems. Meters, BMS and BEM, the nervous system and the brain of the modern buildings, turning raw data into smart controls, and energy savings. And also infrastructure and transport data, the national level picture that decide where the next big projects and job opportunities will be. If you're a student or apprentice or working towards a technical qualification, here's the big message. You're not just learning to fit parts, you're learning to work in a data-driven industry. Every boiler, pump, panel, meter and sensor you touch is part of the bigger story. How buildings perform, how much will they cost and how sustainable they are. So next time you're on site or in a workshop, ask yourself, where is the data coming from, who will be using it and how could it be used to improve the building or the project. These kind of questions turn you from someone who follows instruction into someone who understands the big picture, and that's where real career progression starts. So if you found this episode helpful and you want more down-to-earth explanations of ideas behind modern plumbing, construction and building services, make sure you follow and subscribe to the Copper Connection podcast. Share this episode with a mate on your course or someone on site who's always curious about why we do it this way. You can catch up on other episodes wherever you listen to your podcast, and by following you will never miss new content that can help you smash your qualification and build a future-proof career in the trades. Thank you for listening. I've been Chris Bailey and this is the Copper Connection podcast. We will see you in the next episode.
We'll be back next week. In the meantime, please subscribe and thanks for listening.